Hello everyone! Let us review graphical interpretation of derivatives. As we all know, derivatives could be used to find the extrema, which are the maximum and minimum points in the function, also known as the turning points or stationary points. In the figure, we have points A, B, and C as the turning points. A is the local maximum, B is the local minimum, and C could be our local and global maximum. We use the term local and global here. The global maximum refers to the greatest value the function attains in its domain, and the global minimum is the least value of the function attained in its domain. A is a local maximum. We have another maximum at C. C is the global maximum because its y value is greater than that of the y value of A. So we have here B as the local maximum, local minimum, sorry, and the global minimum of the function is negative infinity, which is exhibited by this arrow. It's going down, so it goes on and on, infinitely small. We can use the first derivative test to find the extrema of the function, but we have to make sure that our functions are differentiable on an open interval a and b. So our function has a turning point at x equals c, where a is less than c, c is less than b, if and only if our first derivative is equal to 0. So at any rate, when our slope is 0, we will get a line, straight line actually, horizontal line. So here is where our slope is 0. Okay, here. And so let's say these are all values of x along the x-axis. So our x here is 0, we put the c, or our x is equal to c, horizontal line. So at this point, C, do we have maximum? So let's say this is point C. This is where x equals C. At this point, do we have maximum? Or at this point where x equals C, do we have a minimum value? So let us find out. So let's illustrate that. Let's choose some points here where A is less than C and B is greater than C. So at x less than c, we have here x less than c to the right of 0. If we have there a slope which is greater than 0, then our slope is positive. And at x greater than c, we have okay, so we shall have here x greater than c, and if our x is greater than c, and at these values our slope is less than 0, or our slope is negative, then we can determine the behavior of the function. So at the right of c, or at the left of c, the function is increasing, and to the right it is decreasing because the slope is negative. So that means we have maximum value. We will obtain a maximum value where our x is equal to c. So if this is a parabola, it looks like this one. This is the vertex, the highest point, and that contains a maximum value. Now, to illustrate the next definition here, if our x is smaller than c and the slope we attain is less than 0, then our slope is negative, a negative slope. That is where our slope is less than 0. And where x is greater than c here, x is greater than c, and the slope is greater than 0, or the slope is positive, then we shall have minimum value at x equals c. So let's illustrate the behavior of this function. It is decreasing at the left of c and then increasing to the right of c. So this gives us a figure that looks like this one. Okay. Where that is our minimum point or the lowest point. Okay. So that's using the first derivative test. We can also use second derivative test to find the extrema. We do the same thing, first derivative to find the turning point, and then we find the second derivative and compute whether it's less than or greater or equal to 0. Let me illustrate that using this example. Let's say our f of x is equal to 1 minus 4x squared plus 2x raised to 4. This is a fourth degree equation, and if we draw that, it looks something like this. Now, we get the first derivative of this. So, our first derivative is equal to negative 8x plus 8x cubed. Now, we would like to find the turning points. So, we equate this function into 0, which is our slope. Now, negative 8x plus 8x cubed equals 0 will give us values of x, which are 0, positive, and negative 1. So drawing this, we have this on the x-axis, we have 0, negative 1, and let's say 1 here. And then you get test point. So again, this is the diagram for your slope, which is 0, a horizontal line. Now, we find value which is here less than to the left of negative 1. So let's say we choose negative 2. So we compute for that. We shall have negative. We care only about the sign. We call this sign diagram. Sign diagram. So what we're going to do is to substitute the value of x in this given equation to find its sign. So negative 8 times negative 2 plus 8 multiplied by negative 2 raised to 3 will give us a negative sign. So let's put it here, negative sign. And then we choose a test point to the right of negative 1, but to the left of 0. So let's choose 0, negative 0.5. And again, Substituting this to the given function here, negative 8x plus 8x cubed will get a positive sign, and we look at the behavior of the function at point where x equals negative 1. So we see that um, it is decreasing and then increasing. So that means we have minimum value at x equals negative 1. So here it's minimum. So we shall have here negative 0.5 and also a certain value for your y. Let's say this point A. And then next we choose another test point between 1 and negative 1 and 0. So let's say uh, we have chosen this already. So we choose between 0 and 1, say 0.5. So substituting that to this equation again, you'll get a sign which is negative. And then we look at the behavior of the function where our uh, where our x value equals 0. So you see it's increasing and then decreasing. Then we shall have a maximum value at x equals 0. So let's say this is B, maximum value at point where x equals 0, and then we compute for the y value of that. Now for the last one, we choose a test point here. So let's say we choose 2. So we get 2. So that gives us positive sign upon substitution here. So positive, and then again the behavior of the function is that we have here negative is decreasing function, it's decreasing and then increasing. So at this point we have minimum at x equals 1. So here, let's say this is point C. So we shall have here 1 and its equivalent y. Okay, that is for the first derivative test. For the second derivative test, we can get rid of this. So from this one, first derivative, we proceed to finding the second derivative of the function. So f double slash x gives us negative 8 plus 24x squared. Now what we're going to do is to calculate, okay, the value of our f double slash. So we will be using these values, the turning point. So we're saying at 0, do we have maximum or minimum? So let's solve. At x equals 0, we shall have f double slash of 0, which is equal to negative 8 plus 24 times 0 gives us negative 8. And our second derivative is greater than, it's less than, it is less than 0. And the way it is defined here, if our second derivative is less than 0, then we have maximum at that point. So that means we have maximum at x equals 0. And that can be verified by the drawing we have here. Our maximum is at point B for our, or at the point where x equals 0. Now we continue. What about if our x equals negative 1? So we get the double slash of that, and then we shall have negative 8 plus 24 negative 1 squared, and it gives us 16. And our uh, second derivative is greater than 0. And if it's greater than 0, we shall have minimum at that point where x equals the given negative 1. So you can see that also in the drawing we have here or from the previous solution. And lastly, let's check how about if our x is equal to 1. So at x equals 1, we shall have f over slash 1 gives us negative 8 plus 24 1 squared is also 16. So it has the same interpretation that when our second derivative is greater than 0, we shall have minimum at that point. So there we have it. We have here x equals 1. Okay, so we use the first derivative and the second derivative. So if it's a first derivative, you stop here. But if you would like to use a second derivative test, you can get rid of this part. So from the first, go directly to the second, and then use the test point. Now, if, however, our first derivative is equal to 0, and our second derivative is also, sorry, is also 0, then it is inconclusive, meaning to say we cannot determine uh, extrema using the second derivative. So we go back to first derivative test to find the local extrema. So that is all for today. You may subscribe so you can get updates. Goodbye, everyone.